Add elevation contour lines and color changes to your 3D printed maps with this new thing I made. To download and use Map Feature Modifier on your own maps, go to ansonlu.com/maps. Scroll down to the second option and click the link for Map Feature Modifier. This brings you to github.com, which has the Map Feature Modifier source code. On the right side, you'll see a releases column, and you can click the latest release. Then download the correct zip file, which has MFM for your operating system. You will need to set up your slicer, your minimal tool change, your map feature options, and then send the print file to your printer. You'll need to change some printer settings in your slicer so that MFM can find certain features inside your G-code. Go to your printer settings in your slicer and click the Machine G-code tab. Scroll down to find the Layer Change G-code option, and at the very end of Layer Change G-code, type in ;MFM Layer Change End. Next, go to the Change Filament G-code, and at the very beginning, add the line ;MFM Tool Change Start. Then go down until you find the last flush sequence for your printer. And in this case for a Bambu printer, it's right before the last flush start. Type in ;extra_purge_insertion. Then go to the very end of Change Filament G-code and type in ;MFM Tool Change End. Then save your printer settings. These steps are listed on the GitHub under Slicer Setup. Printers with a single nozzle can reduce filament waste with the long retraction on cut feature. By retracting the old filament before cutting, the retracted length of filament does not need to be purged when the new filament is loaded. To turn on long retraction on cut, go to your filament settings and go to the Settings Overrides tab. Check the long retraction when cut checkbox and save your filament settings. I recommend that you decrease your flushing volumes to 107 millimeters cubed. This is the minimum flushing volume needed to push filament between the cutting location and the nozzle. If you need additional flushing volume for certain color transitions, you can specify that in the Map Feature Modifier options. Map Feature Modifier optimizes printing order as well as reuses existing tool changes and prime towers in order to decrease the amount of added tool changes and flushing volume in the final code. This results in faster prints and less plastic used. You also need a minimal tool change file, which can be found inside the minimal tool changes folder on the GitHub. Inside, there are minimal tool changes for many common printers, and the current recommended file for the Bambu X1P1 series is the one labeled long retraction with 107 millimeters cubed of flushing volume. These minimal tool changes provide tool change functionality for color changes when there are no tool change and prime towers available for reuse in slicer-generated G-code. You can set up isolines and color changes in the Map Feature Options file, which is a JSON file which can be edited in Notepad or other text editor. For a visual example of how these options affect the features added to your map, we'll use this tall cuboid as well as this example file. The first two options, Model to Real World Default Units and Model 1 to N Vertical Scale, describe the scale of the model to real world. In this example, 1 millimeter in the model is just 1 millimeter in the real world, so we'll set these options to 1. If we used millimeters for model units and meters for real-world units, model to real-world default units would be set to 1000. Model sea level base thickness is the height of the model that corresponds to sea level in real life, which is 0 elevation. The isoline options control where isolines, also known as elevation contour lines, will be placed. In this example, the isolines will start at 5 millimeters in real-world units, continuing every 10 millimeters and ending at 50 millimeters. This means that there will be a contour line at 5 millimeters, 15, 25, 35, and 45 millimeters. The model isoline height option determines the height of the isoline in modeled units. Here, each isoline is 1 millimeter high. Isoline color index is the isoline color identified by the slot number. Isoline color feature types represent the generated printing features that will be recolored as isolines. In this example, the outer wall and external perimeter will be recolored. External perimeter is the term used by Prusa, and outer wall is the term used by Bambu and OrcaSlicer. In this color-coded preview, the outer wall is orange, the inner wall is yellow, the infill is red, and the top surface is shown as a light red. Real-world elevation replacement color represents the color replacement's color range. In this case, it's from 30 millimeters going up to 60 millimeters. The replacement original color index will be replaced with the replacement color index for the duration of the color replacement. Instead of having a matrix to show flush volumes in the slicer, we actually only need to know the previous color of a tool change to determine if we need extra purging volume. Colors that often need extra purge as the previous color in a tool change are dark colors and shiny colors. The option Extra Purge Previous Colors is a list of these colors. I've created options files that fit my released 3D printed maps. These options files can be found in the pre-made options folder on GitHub. After slicing our sample model, in the upper right-hand side, we can click the drop-down menu and select Export Plate Sliced File. If you use Bambu Studio, you need to go to the File menu in the upper right-hand side to find the Export Plate Sliced File and Export G-Code options. Open the MFM application that you downloaded from GitHub. Select your input printing G-Code or plate sliced file, your MFM config options, your minimal tool change G-Code, and you can also set your output G-Code path if needed. Then click Post Process. This will take a few minutes to complete if your model is very big. Drag the MFM exported plate slice file or G-code back into your slicer. There you can preview the final print job with your new features added. You can use the slicer's send or print features to send directly to your printer if your printer supports it. Back to our sample file. Only the outer wall is recolored at the isoline heights as specified in our options. The infill remains the same. Here's an example of what the map model preview should look like once the ISO lines and color changes are added. You can remap the AMS slots on the print screen if you're using a Bambu printer. Make sure every AMS slot is assigned a different color to avoid automatic filament backup. You can also move the G-code file to an SD card to print directly from your printer. If the additional colors don't show up in the preview, make sure you added the additional filament colors before you exported the G-code or plate sliced file from your slicer. Map Feature Modifier also comes in the form of a slicer post-processing plugin so that it runs automatically after slicing. It works in Prusaslicer, Bambu Studio, and OrcaSlicer. The details can be found on my website. There's probably a couple of you wondering why the color here is a bit more green and the color here is a bit more yellow. And that's because I didn't set my flush volume quite correct when switching from the copper color to the white color or the blue color. So when I switch from the copper color to another color on each layer, the printer needs to flush out the old plastic from the nozzle. And in this case, not all of the copper got flushed out. So it mixes with the blue and the white to get this greenish color as well as this yellowish color. And that can be easily fixed in the future by increasing the flushing volume. The downside is that printing will take longer and we will have more waste. Speaking of waste, this is how much purge volume was used, which I guess is also the poop that people want to see. So as you can see, we have blue, green, copper, and some white mixed in. And in between these copper and blue transitions, you can see the greenish color showing through, as well as the gold color from the mixing of the copper and white. So all in all, this didn't actually waste that much plastic because this is very hollow. As for the prime towers, you can see that our script was able to utilize this structure for more than just 2 colors of plastic. This map was initially generated with just gray and blue colors, and our script is able to use it for the color as needed on demand each layer. So here you can see there's gray, blue, and gold being used all in the same tower. There's probably white in there as well, but it's just too light colored to see. I've also created a scale and legend for this map. In this we show the scale bar, the land colors, as well as the high elevation color over 1600 meters, the contour lines in copper, as well as the blue water. And some people have had some confusion. So this scale is for this large map here and not that small California outline. As tricolor filament is printed, the color that's exposed to the user depends on the direction of the nozzle as well as the side of the object that's shown to the outside. In this case, the purple is on this side of the object, while there's also blue and green. I got the same color on the same side of each of these objects by positioning the objects on the build plate in the same orientation that they were generated in, so that each time the filament prints, the green will always be exposed on the side facing us right now. And also, on the other side, we will have purple facing the side that was facing away from us, as well as blue, if we look at it this way. For numbering the 4 slots of the AMS, it's T0, T1, T2, and T3. Bambu printers come from the factory pretty reliable, but their nozzle wiper can be improved. I'll link to the one that I've used that includes both a PTFE tube and a silicone wiper. I've used it to pretty good effect, and it's produced an entire bucket of poop without issues. You can find recommended printing settings as well as map specifications at my website, ansonliu.com/maps. My 3D printable maps are available for free on MakerWorld and Printables. You might be thinking, hey Anson, why don't you just find and replace the tool indexes? When you recolor entire layers, you'll end up with an oil slick effect when top surfaces line up perfectly with isoline layers. So instead of being layer aware, we need to be feature aware so that we can selectively recolor certain features such as the outer wall and ignore the top surfaces. Slicers tend to print islands completely, meaning that the outer and inner wall and infill of a disconnected area is completely printed before the outer and inner wall and infill of another disconnected area is printed. So you're probably seeing the issue already. If we recolor only the outer walls, we need to do a tool change every single time we switch to another island. In addition to being feature aware, we need to make our feature G-code relocatable and modifiable, in addition to tracking state throughout the entire post-processing. We reuse existing tool changes and prime towers, as well as add our own in order to take advantage of slicer optimizations and reduce wasted plastic. We end up reordering the printing features so that the outer walls of the same color all finish printing before moving on to the inner walls. It gets even trickier when features cross layers. For the assembly developers out there, yes, this is a framework for isolating and injecting G-code gadgets.
I love the attacks, I love the defenses, because what they prove is that gadgets are eternal.
I'll make a separate video on how this all comes together. Thanks for watching. I hope you have fun 3D printing my multicolored maps.